Hi, welcome to HelpYourMath.com. Today's video we're going to be covering synthetic division, and in this case we're using synthetic division to find all real solutions of the polynomial x cubed minus 19x minus 30 equals 0. Now here we see that we have to use synthetic division to solve this, but before we even begin there's a few things we have to cover because we're using synthetic division, and there's a few things you need to know before using synthetic division. So firstly, to find all the real zeros of this equation, we should be using something called the rational zero test. And the rational zero test takes the coefficients of the first term and the last term, and we create a quotient called P over Q. And so the rational zero test here in this case, our rational zeros are going to be based on the quotient of P over Q, where P is the final number, the constant, and Q is the four leading coefficient of the x cubed term. So our P term here is going to be negative 30. Our Q term is going to be positive 1. And what we're looking for here is all the possible factors of negative 30. So we could divide all the possible factors of negative 30 by all the possible factors of our Q term, which is 1. And all the possible factors of 30 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 5, plus and minus 6, plus and minus 10, plus and minus 15, and plus and minus 30. Now I want to just make sure that all these numbers divide 30 and see if I missed any numbers that make 30. So 1 goes into 30 perfectly, so there's 2 that makes 15, 3 makes 10, 5 makes 6, which I see 6 is here, 10 is here, 15 is here, and 30 is here. So I think I have all the possible factors of 30. And what I want to do is I want to divide these factors by all the possible factors of our leading coefficient, which is 1. And that is only going to be plus and minus 1. Now, because I'm dividing this by 1, I could just ignore my denominator. My P divided by Q is just all the factors of the last term, which are plus and minus 1, 2, 3, 5, 6, 10, 15, and 30. Now, because I'm using synthetic division, I want to try each of these possibilities. So I'm going to start with the positive 1, then move to the negative 1. After I check those and they don't work out, I'm going to try plus 2, and then negative 2. And then accordingly until I find the first real zero. Now this is a tedious task, which you could probably use Descartes' theory of variation to solve furthermore. But in this case, Descartes' theory of variation is just a little harder to solve, and I'm going to explain to you exactly why right now. Now basically here our function is x cubed minus 19x's minus 30. And we have a missing condition right? And that's the x squared term. We don't know the value of the x squared term. So what we want to do is put the 1x cubed, for the 1 being the coefficient of the x cubed. We're going to add the 0x squared and continue to leave all the other terms following. Now, the big important thing about doing this is that when we're doing synthetic division, just like long division, we need placeholders for the missing terms. Now that we have the placeholders, what we're going to do is we're going to troubleshoot the solutions to this. And we're going to start with x equaling 1 as the first real solution for this problem. Using synthetic division, we put this irregular box, which is nothing like what we know about division. We're going to take the coefficients of our polynomial, and we're just going to place the coefficients in that box. Leave a little spacing so that you can do the synthetic division for this term. In here we put the remainder, and what we do first is always bring down the first term. So here we're going to bring down the 1, and then we take this 1 and we multiply by this 1, and we place the product here. The next step is we take the sum of the two terms. 0 plus 1, 1. Again, we take the product of this times this. 1 times 1 is 1. Negative 19 plus 1, negative 18. Now we do again repeat the process. 1 times negative 18, negative 18. This, when we sum them up, negative 30 plus negative 18 is negative 48. This is not 0, so that means x equals 1 is not a solution. So we're going to move on to the next term and see if it works. Our next term we're going to do is going to be negative 1 because we tried the positive 1. So we'll say x equals negative 1. And we'll repeat this process. We have 1, we have 0, negative 19, and negative 30. Our remainder box, we continue the same process of, again, the 1 comes straight down and we multiply. 1 by negative 1 It's negative 1. We add these two, we get negative 1. We multiply these two. That's positive 1. So we put the 1 here and we add these two. It's negative 18. Now we multiply these two. That gives positive 18. When we add these two, we get negative 12. Now here this is not 0 either, so we know that x cannot be negative 1 either. So neither of these two are solutions. So we could disregard the 1 as being a solution. Now we're going to move on to the 2. But let's make a more educated guess about this, right? Because we see here we have this being negative 48, this being negative 12. And I think the negatives are getting closer than the positives. So I'm just going to take a shot in the dark and try both of them again. So let's start with 2 and see what happens when we try positive 2. So we have 1, 0, negative 19, and negative 30. We have our remainder box. We bring down the first term, and we multiply. That gives us 2. Add them. This gives us 2. Multiply. That gives us 4. Add them. That gives us negative 15. Multiply. That gives us negative 30. Funny enough, we add these and we get negative 60. This took us the wrong direction, and we should have known better because this was way further than this. Let's try the other one and see if it gives us any more closure. This is not the correct solution then. So x is not 2. Let's try x is negative 2. So now we have 1, 0, negative 19, negative 30. Remainder box. And we are looking for a remainder to be 0 to know that this is perfectly divisible. So let's continue. We bring down the 1. 1 by negative 2 is negative 2. Negative 2 comes down. 0 plus negative 2 is negative 2. This times this is positive 4. This plus this, negative 15. This times this turns positive. 2 times 15 is positive 30. And we get our first real 0. So we know x equals negative 2 is one of the solutions to this problem. Let's make a note of that. First solution is found. Now what's left over here? These are coefficients to what's left over. Now if you remember when we transform these coefficients into this, what we have left are 3 terms. And what we want to do is isolate the last term, right? And just remove this term and just take these last 3 terms. So our coefficients for the last 3 terms we see here are now going to be x squared with a 1 in front. That's the coefficient. The next term is an x term, and we have a negative 2 in front of it. And the last term is the constant, which is negative 15. And we could continue using synthetic division to solve this. But this doesn't look so hard, right? At this point, we could continue doing synthetic and use the same rule we did, or we could just factor. In this case, I think factoring is the easier bet, right? So we have x squared minus 2x's minus 15. We know the 2 factors both have an x in it. Because the last term is negative, 1 is plus, 1 is minus. It doesn't matter which order you place them in, right? The factors of 15 that add up to negative 2, and it's a negative 15, right? So let's factor this out. We have negative 1 and 15, negative 3 and positive 5, negative 5 and positive 3, and negative 15, positive 1. This is 14, this is 2, this is negative 2, and finally negative 14. We're looking for the negative 2, so we know our factors are negative 5 and positive 3. So the 3 goes here, the 5 goes with the negative, and we solve each one. So x plus 3 equals 0, x minus 5 equals 0. We subtract 3, these go away, and x equals negative 3. There's our second solution. And our final solution, we add 5 to both sides. These go away, and we get x equals 5. So there we go. We have all 3 solutions to this problem. We know x equals negative 2, x equals negative 3, and x equals 5. Thank you.